Okay, welcome to this video on relative atomic mass and moles. This is an introduction to the C4 calculations in chemistry module for AQA GCSE. Could be useful for anyone year 10 and above, year 9 even, studying chemistry who just wants a refresher. So the first thing to deal with is relative atomic mass. Now if we think about our structure of an atom, we have the nucleus surrounded by shells of electrons, and in this case I've drawn lithium, so 3 electron species. Now if we look at lithium on the periodic table, lithium has 2 numbers associated with it. It has 3 and 7. This 3 tells you the number of electrons. There they are, 2 in the first shell, 1 in the second, and this number at the top here, this is the mass number. The massive number is the mass number, apart from hydrogen, which has 1 and 1. That's the way to remember it. Now the relative atomic mass of a lithium atom is 7. We can then come up with something called MR. Now MR is the sum of all these atomic masses for a molecule. For example, carbon dioxide, CO2, is a combination of carbon and oxygen. If you look at these on the periodic table, carbon has the numbers 12 and 6, and oxygen has the numbers 16 and 8. So, the mass number for carbon is 12, the mass number is the massive number, and the mass number for oxygen is 16. To find the MR for this, we add the mass number for carbon, 12, 2, because we said it's the sum of the atomic masses, the mass number for oxygen, 16. Now, there are 2 oxygens, because it's CO2, one molecule of carbon dioxide has 2 oxygens. Therefore, we need to add another 16 to account for that second oxygen atom. In total, that makes 44. That is how we calculate MR. So, have a try of this. Calculate the MR for water, sodium chloride, and third, let's have N2. So you might want to just pause the video and then work out these on your pad. Brilliant. So, welcome back. Let's talk through these. So, hydrogen, you should have seen that the mass number is 1. Oxygen is 16. So we've got 2 times 1, which is 2, plus 16. Hopefully you got 18 for this. You will have needed a periodic table. Sodium is 23 and chlorine is 35.5 on the periodic table. The reason for that is to do with isotopes, but I'm not going to go into that on this video. And that is 58.5, so hopefully you got that. N2, each nitrogen is 14, so we're looking at 28 as the total. So that's how we calculate MR. Now we need to consider the mole. Some precious commodity here. Given the current situation, this is a real abuse of toilet roll. There we go, it's probably about £5 worth in today's market. We're now looking at the moles. A mole is simply 6.02 times 10 to the 23 atoms. Now the reason we say that is because atoms are so small, it's difficult to quantify how many atoms we have in, say, 5 grams of a substance. It's inconvenient to say the big numbers. So, this number of atoms is equal to 1 mole, and that's all a mole is. Now we can link moles and MR with mass in grams using the following equation. This is mass MR mole. Massive Mr. Mole. That's how I remember it. These triangles work in the way that you cover up what you need to find out in order to get a number of equations. So if I wanted to find mass, that's MR times mole. If I wanted to find mole, I cover that up. It's mass divided by MR. MR, we already said, is what we learned earlier in the video, of molecular mass. If we want to work out MR, then we do mass divided by moles. So I've got 3 equations there for the price of 1 by memorising this triangle. So let's look at what a typical question might look like. So a question might say, if or how many moles in 6.2 grams of CO2? Okay, so that could be a typical question. So what do? Well, first of all, I want to rearrange this triangle to get a formula for what I want to know. So moles are equal to mass over MR. My mass is 6.2 grams. And my MR, if you actually rewind the video a little bit, I showed you how to work it out, is 44. I plug that into a calculator and I get my value. So that's how we do moles calculations as an introduction. A mole is 6.02 times 10 to the 23 atoms, and MR is the sum of the mass numbers. Okay, we add them all together and you get the MR of your molecule. I hope you enjoyed the video. Sorry for the needless waste of loo roll. Please like, comment and subscribe. I'm being asked to advertise, and I'll see you in the next video. Thanks very much.